Here is a complex shape, also known as a composite figure, that I'm going to be demonstrating how to solve and find the area with my students. Now, this shape can be broken down into other polygons, and we can find the area of the polygons that make up this shape and add those areas together to get the total area for the shape. Now, I have students in the classroom. When you look at this shape, boys and girls, what does that put in your minds that you want to break that down as? What do we want to make that into? And we could break it into several different ways. All right, Bryce?
I'll break it into a rectangle.
Okay, so we can make a rectangle out of it. And I'll go ahead and do that. I'll put a line here. Okay. So right now it looks like a hexagon and a rectangle. Now if this were a regular hexagon, there'd be a pretty much easy way to figure out what the area of it would be if we had the apophthegms figured out and that sort of thing, but we don't. And it's not a regular hexagon, so we need to do something about it. We can either convert that into a rectangle and two triangles, or we could convert it into two isosceles trapezoids. How about we do that, boys and girls? You want us to do that? Okay. So we'll go ahead and I'll put a line in it right here, and we'll have two isosceles trapezoids. Now, we've got it broken down into three shapes. All we need to do now is figure out the area of those individual shapes and then add those areas together. So the first thing I want to do is the easy one, and that is find the area of the rectangle. The formula for finding the area of a rectangle is area equals base times height. And here our base is 19 millimeters and our height is 4 millimeters. So if I want to do this one mentally, I could say 19 times 4 is 76. Now I'm going to go ahead and put 76 millimeters squared. So that is the area of our rectangle. Now all I have to do now is figure out the area of just one trapezoid and times it by 2. I could do that. There's another trick I could do, but I'm just going to do it this way. Now the formula for finding the area of the trapezoid is area equals 1/2 base times, it should be height. 1/2 height times base 1 plus base 2. Now I could do this without having to wind up multiplying the area of one trapezoid by 2, but I'm going to go ahead and do it this way because I don't want to confuse anybody since we're kind of new at this. What I need to do is figure out what is the height here. Now it's told to me that from this point to this point it's 12 millimeters. From this point to this point is 4, so I need to figure out what is this much. What's this much? And then divide it by 2, or just find out from here to here. So what do you think, boys and girls, you've got a second to look at it, what do you think why the height would be? Okay, so from here to here would be 8, because 12 subtract 4 gives us 8. But if I want to know from here to here, what will that be? 4, because 8 divided by 2 is 4. So I'll say 4 for the height. Now, one thing I want to point out is this value here. It says 5 5/8 millimeters. Is that anything that we need, or is that extraneous data? That's extraneous data. We don't need to know this side length at all.
Katie Edwards, come to the office, going home.
Now, this base from here to here is how much? How much is this?
Morgan Dooley, come to the office, going home.
All right, Carissa.
19 millimeters?
It's 19 millimeters because from here to here is 19, then from here to here is 19. And how much is this base? 11. It says it right there. It's labeled right there for us. All right, so half of 4 is going to give us 2. 2 times, and 19 plus 11 is going to give us, it's going to give us 30. And 2 times 30 is 60. and that's 60 millimeters square. And so this trapezoid is 60 millimeters square, this trapezoid is 60 millimeters square. Okay, now let's go ahead and add up this value, and this value, and see what we get. 60 plus 60 is 120, and 120 plus 76 is 196. And our unit measure is millimeters square. Millimeters square. Now, if I were to attach a math practice to this, I would say that I used what I know about finding the area of various polygons to figure out the area of the entire shape. Does anybody have any questions in here for me? Anybody have any questions for me? Alright, how many of you feel confident that after seeing the last couple demonstrations you can do these? Okay, I will be uploading these videos to YouTube to help you if you need to. Good luck tonight.